Hi, in this video I'm covering section 2.4 on linear functions. So we saw in section 1.3 the definition of a function, when a relation is a function, and the simplest type of function is a linear function. So that's what we're doing in the next two sections. 2, 4, and 2.5, we're going to be studying linear functions and equations of lines. So here's the definition of a linear function. A function f is linear if, for real numbers a and b, f of x equals ax plus b. And we want the function to be, we want a to be not equal to 0. Because if a is equal to 0, then the function is a constant. That is the value of the function. The y value is the same for any value of x. So this is on page 219. And the reason why a linear function is called linear is because the graph is a line. So the graph of a linear function is a straight line. Okay, so we're going to see examples of graph linear functions. We're going to graph each linear function and give the domain and range. So in the definition, if the number that multiplies x is not 0, the domain and range are both all real numbers. If a is 0, if you have f of x equals a single number, the range is going to be the single value b. So the first function is f of x. Let's call this number 1. That is the opposite of 4/3 times x plus 4. So we're going to plot 3 points. We're going to plot the x-intercept, the y-intercept, and a checkpoint. So usually when you graph a straight line, you only need 2 points. And the intercepts are good 2 points to start with. But if for some reason the intercept is a fraction, we try to avoid those. And we're going to plot a checkpoint that doesn't involve fractions. So we're going to plot 3 points. Those are the x-intercept, the y-intercept, and a checkpoint. Okay, so we are doing first the x-intercept. If we want to find the x-intercept, we can rewrite the function as y equals the opposite of 4/3 x plus 4. So the x-intercept occurs when y is equal to 0, so we let y be 0. So minus 4/3 x plus 4 is equal to 0. That's a linear equation that we did before. That was one of the first things we did in this course. So the opposite of 4x or 4/3 x is equal to -4. Solving this equation for x, that's something we did before. Multiply both sides by the reciprocal of -4/3. So x is equal to 3. Okay, so we know the intercept, the x-intercept is 3, 0. Let's find out the y-intercept. The y-intercept occurs when x is equal to 0. Okay, so all we do is plug in x. So y is -4/3 times 0 plus 4. But any number times 0 is 0. So y is 4. And the x-intercept is 0,4. So that's usually all you need, 2 points. Sometimes the intercept might be fractions. So what we're going to do is plot a checkpoint. There are times when this is not necessary, but in the homework, they are going to ask you for 3 points. And they may just give you, they are just going to give you the x coordinates if they want you to plot a checkpoint. Okay, so I'm going to rewrite the equation. The equation was y equals the opposite of 4/3 x plus 4. We are going to choose the point. So the coordinates don't involve fractions. We already chose x equals 3. I mean, I'm looking for a number that is divisible by 3. So 3 is divisible by 3, but we already found that point. So if I choose something like x equals 1, I don't want to plot a point with fractions. Or x equals 2, that also involves fractions. So I have a couple of choices. One could be x equals 6, or another one could be x equals -3. So let's do that. Let x be -3, and y is -4/3 times -3 plus 4. But -4/3 times -3, that's going to be positive, and the 3's cancel out. So this is going to be 4 plus 4, or simply 8. And the checkpoint is -3,8. Okay, so what the last thing we're doing, we're going to sketch the graph of this line, of this linear function. The linear function is going to be a straight line. We found the intercepts, and we found another point. Okay, the x coordinate was 0,3, no, 3,0. The checkpoint was -3,8. Okay, so the points are again -3,8, 0,4, and 3,0. So let's connect the dots. In this case, the graph is a straight line. And there it is. So that's the graph of the line. We have the two intercepts, and we have a third one. So next example, the first one was example 1. We did f of x equals the opposite of 4/3 x plus 4. Example 2. The function is f of x equals -2. The thing about this, the thing about this is that the y value is always -2. So the value of y is always -2, regardless of the value of x. Okay, so pick an x value, anything you want, and the y coordinate is going to be 2. Like f of 0 is 2, f of 1 is 2, f of 4 is 2, f of 50 is 2, and so is -2, and so on. Or f of -25 is -2, and so on. So some points. So since the value of y is always the same, some points are going to be, we can list as many as we want, but some are -2, -2, -1, -2, 0, -2, 1, -2, and 2, -2. And this is what the graph looks like. So we're going to indicate the axes, x and y, and some of the tick marks. Okay, so some points on that line are going to be -2, -2, -1, -2, 0, -2, 1, -2, 3, -2, and so on. And this one in particular, the x-intercept is 0, -2. Not the x-intercept. Actually, there is no x-intercept. The y-intercept is 0, -2. And there is no x-intercept. So that's a horizontal line that is never going to cross the x-axis. So there is no x-intercept. So the domain is all real numbers. And the range is a single number. Is the set consisting of the single number -2. So I didn't write the domain and range of the last one. But in the first example, the domain and range are both all real numbers. So the domain is going to be all real numbers. It keeps rising to the left and falling to the right. So the domain is all real numbers. And the range is also all real numbers. And number 3. This one is not going to be a function. So I'm going to write this separate example. We are going to graph. We're going to graph the relation x equals 3 and give the domain and range. Okay, so if x equal to 3, the value of x is 3 regardless of the value of y. Okay, so some points on the graph are 3, -2. So now the x value is the one that is fixed. 3, -2, 3, -1, 3, 0, 3, 1, and 3, 2. And if we graph this line, or if we graph this relation, the graph is going to be a vertical line. Okay, so that's what? That's 3, 2, 3, 1, 3, 0, 3, -1, and 3, -2. So graph the vertical line. So that's the graph of the relation x equals 3. The x-intercept is 3, 0, and there is no y-intercept. The graph is never going to cross the y-axis. So the x-intercept is 3, 0. There is no y-intercept. This graph never crosses the y-axis. The domain is going to be a single number. The single number, or the set consisting of the single number 3. Okay, so the domain is, we write this within braces, the same way we wrote the solution set of a linear equation, and the range is all real numbers. That will keep rising up and falling down without moving forward or backwards. And that one is within parentheses, that's negative infinity to infinity. Okay, so one way to write a linear function is as f of x equals ax plus b. You can also write the equation of a line that is not necessarily a function in standard form. So equations of lines. So any non-vertical line is a function, but a vertical line is not a function. So equations of lines are often written in the form ax plus by equals c, known as standard form. For example, let's graph the line 2x minus 3y equals 6. And we're going to give the domain a range. We're going to include 3 points. So there's no need to write this as a function. There's no need to write this as a function, f of x equal to something. What we're going to do is find the intercept and a checkpoint. So we're going to find the intercepts and a checkpoint. So we're going to start with the x-intercept. To find the x-intercept, we let y be 0 and 2x minus 3 times 0 equals 6. So 2x is 6 and x is 3. The x-intercept is 3, 0. Now let's plot the y-intercept. To find the y-intercept, we let x be 0. We plug it in. So the opposite of 3y is equal to 6, and y is -2. The y-intercept is then 0, -2. So that's enough to get the graph of a function, but we're still going to do a checkpoint. On the homework, they're going to ask you for a checkpoint. Okay, so for a checkpoint, we can look for something that we can look for a y value or something that something to make it work, that makes it work. Like if we multiply x, or if we let x be a multiple of 3, once we solve for y, the solution for the solution is going to be some integer. Or the other thing we can do, if we let y be a multiple of 2, once we solve for x, the value is going to be an integer. So we can let y be positive 2. So let's do a checkpoint. Let y be 2. And 2x minus 3 times 2 equals 6. So that's 2x minus 6 equals 6. Add 6 to both sides. 2x equals 12. So x equals 6. And we have a checkpoint, 6, 0. So the line will contain these 3 points, 3, 0, 0, -2, and 6, 0. Okay, let's do that. Okay, so again, our points are, the points we found were 0, -2, 3, 0, and actually that was that was 6, 2. There's a mistake there. That was 6, 2. Okay. And yes, we also got y equals 2. Okay, so let's plot the points. Finally, we got 0, -2, 3, 0, and 6, 2. Okay, so that's the equation of the line. The domain is all real numbers. The domain and range are both all real numbers. So the domain is -infinity to infinity, and the range is also -infinity to infinity. Okay, so far we have been plotting equations of line, or we have been drawing the graphs of lines by point plotting and by using intercepts. So an important characteristic of a line is the slope. So the slope is a numerical measure of the steepness and orientation of a line. Okay, so let's say we have the graph of a line passing through 2 points. Let's say that the points are x1, y1 and x2, y2. So one way to measure the stiffness is by considering the horizontal displacement, that is the change in y from x1 to x2. This distance is going to be x2 minus x1. And the vertical displacement from y1 to y2. So the distance from y1 to y2 is y2 minus y1. So to define the slope, we're going to use this Greek letter delta. This Greek letter stands for delta. And it stands for changing. The slope is then the rise over the run. The rise is the vertical displacement. The rise is the change in y, and the run is the change in x, or the horizontal displacement. Where the change in y is y2 minus y1, and the change in x is x2 minus x1. So I'm going to copy the definition of a slope. And that's denoted with the letter M. Okay, so the slope M of the line through the points x1, y1, and x2, y2 is given by the following: by the rise over the run, or the change in y over the change in x, or y2 minus y1 over x2 minus x1, where the change in x is not 0. So as a note, the slope of a vertical line is undefined. Because if a line is vertical, the x value is always the same. To try to calculate the slope, you would not have any, well, you wouldn't have any displacement. You would have some division by 0. So when you have a vertical line, even in practice, you cannot talk about the slope. Well, the slope is undefined because there is no run, and you cannot even say whether the line is rising or falling because it's not moving forward or backwards. So the slope is undefined. If you try to use a formula, the slope formula, the y values are going to be different, but the x values are going to be the same. So you have some division by 0. Okay, so we're going to do examples of using the slope formula. We are going to find the slope of the line passing through the given points. So I'm going to write all this together. The first set of points is -3, 7, and 2, -4. The next 2 points are 2, -1, and 2, 4. And in C, the points are -3, -5, and 1, -5. Okay, part A. The slope that we denote by the letter M is the rise over the run. The rise is the vertical displacement, so that's going to be the change in y. So let's say that the first point is x1, y1, and the second point is x2, y2. So that's going to be -4 minus 7 over 2 minus -3. -4 minus 7 is -11, and 2 minus -3 is going to be 5. So that's going to be the slope. The slope is -11 over 5. Or you want to write the negative in the middle, that's fine too. So whenever the line runs 5 units, it's going to fall 11 units. Or if it goes 3 units backwards, it's going to rise 11 units. B. The rise or the vertical displacement is going to be 4 minus -1 divided by 2 minus 2. So that line is going to be vertical. So 4 minus -1 is 5. 2 minus 2 is 0. You have division by 0, and the slope is undefined. This line is going to be vertical. And see, the slope is the vertical displacement. That's going to be -5 minus -5. So same y value. Looks like it's not going anywhere. Vertical is not going anywhere, over 1 minus -3. But -5 minus -5 is going to be 0. And 1 minus -3 is 4. So the slope is 0. And the line is going to be horizontal. So that's the next note. The slope of a horizontal line is 0. Okay, we're going to do, okay, so the first form of the equation of a line is the slope-intercept form, and that's going to be the most important one. So let's say you have the equation of a line, or you have the graph of a line. That has y-intercept 0, b, and has slope m. Okay, so the y-intercept is 0, b, and the slope is M. And let's say it passes through some other point, xy. So if xy is any point on the line, if xy is any point on the line, then the slope formula says that, okay, so the y-intercept is 0, b. And from the slope formula, you know that the slope is the change in y. So that's the change from b to y over the change in x, which is x minus 0. But x minus 0 is x. So m is y minus b over x. And mx is y minus b. And finally, solve for y by adding b to both sides. And mx plus b equals y. Or y equals mx plus b. So this is actually in the next section, but it's important to mention this before. And a line aligned with y-intercept, aligned with slope m and y-intercept 0, b has equation y equals mx plus b. So this is the slope-intercept form of the equation of a line. And now, without finding points, determine the slope of the line with equation 5x plus 3y equals 10. Okay, so we're not going to plot any points and then use the slope formula. All we're going to do is solve for y. So solve the equation for y. I have 5x plus 3y equals 10. So solving for y, subtract 5x from both sides. And then divide everything by 3. And y, it's the opposite of 5/3 x plus 10/3. Okay, and the slope is negative 5/3. So the slope. And not only that, we also know that the y-intercept is 10/3, or 0 negative 10/3. So another situation is knowing one point, knowing any point, and the slope. So this is what we do next. Yeah, and this is why sometimes it's more convenient to plot checkpoints, because the y-intercept, in this case, the y-intercept involves fractions. So we are going to graph the line, passing through the point. Negative 1, 3. And having slope negative 4/3. Okay, so we're going to use the fact that if the slope is negative 4/3, either the rise is negative 4 while the run is 3, or the rise is 4 while the run is negative 3. And we can plot 3 points quickly. Okay, so the point they gave us was negative 1, 3. Okay, so they gave us the point negative 1, 3. And okay, I need a few more tick marks. And if the slope is negative 4/3, whenever you run 3 units, you fall 4 units. So run 3, fall 4, up to negative 1. Or run 3 units back, rise 4 units. So 3 back, rise 4. And we can indicate. So that's 3, negative 4, negative 3, and 4. We got the points negative 4, 7, negative 1, 3, and 2, negative 1. Okay, I made it look like the y-intercept is 0, negative 2, but it's not. Yeah, the y-intercept is not 0, 2. Okay, so I'll try it one more time. Okay, it doesn't look very straight, but that's the idea. Okay, so I was talking also about the slope. So it tells you the steepness, it gives you the steepness of a line, but also the orientation. So I'm just going to read this part. That's on page 225. So a line with positive slope rises from left to right, because both the rise and the run, the rise and the run are both positive or both negative. So they both increase or they both decrease. A line with negative slope falls from left to right. So the rise and the run have opposite signs. So when one increases, the other one decreases, and the line is going to be falling. A line with slope 0 neither rises nor falls. If the slope is 0, there is no rise. So no matter how far you run, the line is never going to rise. And the slope of a vertical line is undefined. It's undefined because in the formula, you have division by 0, but also if you're not running anywhere, you cannot tell whether the line is rising or falling. A generalization of the slope, and that's a very important concept in calculus, is the average rate of change. Okay, so I'm still going to read this part. So we know that the slope of a line is the ratio of the vertical change in y to the horizontal change in x. Thus, slope gives the average rate of change in y per unit of change in x, where the value of y depends on the value of x. So if f is a linear function defined on the interval a comma b, then we have the following. So I'm going to write this formula. For any function, again, this generalizes the slope, and that's important, especially in calculus. For any function f, the average rate of change of f over a comma b is f of b minus f of a over b minus a. So I'm looking at example. Let's see. So I'm looking at an example at an exercise on page 66. So on number 66 on page 229. So I'm going to copy that. You will interpret you will find and interpret the average rate of change illustrated in the graph. And the graph is, I'm going to copy that. This one is a line, so the average rate of change would be the slope. We're on page 229. And let's make this bigger. Okay, so the average rate of change, we can identify a couple of points. We can identify the point 0, 0, and 150. Or if you want to be completely sure, that would be 2, 100. So the average rate of change is going to be 100 minus 0 over 2 minus 0. Or 100 over 2, or 50 over 1. The units we're using is the amount saved per month. So that's $50 per 1 month. So every month, so a person saves $50 every month. That's the meaning of the slope in this context. Number 70. On the same page, the total amount spent on plasma flat panel TVs in the United States changed from 5,302 million in 2006 to 1,709 million in 2013. Find and interpret the rate of change in sales in millions of dollars per year and write the answer to the nearest 100th. So we know that in 2006, the sales were 5,302 million. Okay, so we can write a point, 2006 and 5302. And in 2013, the sales were 1,709 million. That's another point. 2013, 1709. The average rate of change. It's going to be the change in Y, so that's 5302 minus 1,709 over 2013 minus 2006. So that's going to be, well, actually I'm making a mistake. Yeah, that's negative because the change are decreasing, so the sales must be negative. So yeah, so this actually 1709 minus 5302. And this is negative 3,593 divided by 7. This is approximately to the nearest 100th. This is negative $513.29 million, or to the nearest 100, that's correct, $1 million every year. So the sales decreased by 513.29 million per year. And one last application I'm doing is to cost, revenue, and function. Cost, revenue, and profit functions. Okay, so we have 3 functions. We have first the cost function. The cost function gives you the cost of producing X items. The cost function is going to be C of X equals MX plus B. Okay, so this is the cost of producing X items. Where B represents the fixed operation costs and M, the cost of producing each item. Okay, so B is going to be any fixed cost. Like maybe you are paying rent, the rent is going to be fixed, or maybe you are hiring workers, and and you're paying those employees monthly, those type of things, or yeah, some other things like that you're going to pay no matter what. Maybe for the internet you pay a flat fee, so those type of things are going to be fixed. And the cost of producing each item, that could be something like the cost of material, like how much do you have to pay for material for each item. Okay, the next function is the revenue function. So the revenue function is R of X equals PX. Okay, so this is the cost. Of selling X items, where P is the price per item. And the third function is the profit function. Okay, the profit function, P of X, that is R of X minus C of X. That is the revenue minus the cost. This is the revenue from producing and selling X items. Okay, so we're going to do the last problem, number 78. To finish this section, on page 232, number 78. Okay, so there's that. We're going to do number 78. So you have 4 situations, but I'm only doing one of them. Okay, so this is the one we're doing. We're doing number 78. So a firm will break even. There is no profit and no loss, as long as the revenue just equals the cost. Okay, so that you are hoping that this is your last case scenario, that you don't end up losing money. The value of X, that is the number of items produced and sold, where C of X, where the revenue equals the cost, is the break-even point. Assume that each of the following can be expressed as a linear function. We're going to find the cost function, the revenue function, and the profit function. And at the end, we're going to find the break-even point and decide whether the product should be produced given the restrictions on sales. So the cost function the cost of producing X items is going to be C of X. Those are going to be the price per item. So it costs $150 to produce each item, plus 2,700 as fixed costs. That could be different things, like renting the local, employee salaries, maybe internet costs, renting some equipment, those things. The revenue function is the revenue from selling X items. So if each item costs, if you're selling each item for $280, the revenue is going to be 280 times X. So 280 per item multiplied by the number of items. And the profit function from producing and selling X items is R of X minus C of X. Is the revenue minus the cost. This is 280X minus 150X plus 200 plus 2,700. Okay, so that's P of X. The profit is then 280X minus 150X is 130X. And then minus 2,700. So we have the cost, the revenue, and the profit. And they are asking us for the break-even point and decide whether the product should be produced given the restriction on sales. So the break-even point occurs when the revenue equals the cost. Okay, the break-even point occurs when the revenue and the cost are equal. Where the revenue is 280X and the cost is 130X or 150X plus 2,700. Subtract 150X from both sides and 130X is 2,700. So X is 2,700 over 130. This is approximately 20.8. So the break-even point is actually not an integer, but there's a problem. So they are asking us whether the product should be produced. We saw that the break-even point is at approximately 21 units sold, but no more than 25 units can be sold. So looks like it's not worth it. So since no more than 25 items can be produced, or can be sold, the product should not be produced. Yeah, so no more than 25 items can be sold, and your break-even point is almost 21, so it looks like it's not worth it. The maximum profit would be 550. So P of 25, the profit function is 130X minus 2,700. and this is 5,500. So no, 550, not 5,500. This is 550, and this is the maximum profit. So it's not worth it. If the fixed cost, if the fixed operational costs are 2,700 and all you can make is $550, looks like it's not worth producing this item and try to sell all the items. So this is it. Thank you for listening.